How do you reflect a point using a vertical and a horizontal line? This is the only video for these notes, and by the end of the video, after looking at examples and getting some notes and some information, you'll know how do you reflect a point using a vertical and horizontal line. Here's a reminder of how your notes should be set up to take notes from this video. Let's review some transformations that we have encountered thus far. We first discussed a translation, which is a slide, and a translation slides an object a fixed distance in a given direction. The original object and its translation have the same shape and size, and they face in the same exact direction. So remember, translations are really just slides. So here's a picture for you to tie that in with. Notice that their original position was here, and then they slid down, and now here's their new position for the translation. And here's an example looking at geometric figures on a coordinate plane. A rotation is a transformation that turns a figure about a fixed point called the center of rotation. And remember, we discussed that the center of rotation could be inside the shape, in the center of the shape, or it could also be anywhere around that shape. An object and its rotation are the same shape and size, but the figure may be turned in a different direction. So here's an example. This really doesn't make much sense. I guess it's just a world view. Okay, that's the rotation. Here is a Ferris wheel. And then here's the letter R being rotated right over here. And notice this is the center of rotation. Here's the center of rotation, and this would have a center of rotation too. And now here is the definition for reflection. A reflection can be seen in water, in a mirror, in glass, or in a shiny surface. An object and its reflection have the same shape and size, but the figure faces an opposite direction. So think about in a mirror, for example, right and left are then switched. So this is a mirrored image. This point was here, now it's flipped to this side. So here's the original, here's the image, and this red line is our line of reflection. It would take place of the water, mirror, glass, or shiny surface to reflect our image. We're going to discuss on how to do that with just one coordinate point. So just a reminder, line reflections are flips. You're just flipping the object. And here's some examples of seeing objects being flipped. Here is some more information for you. The line where a mirror can be placed is called the line of reflection. And the distance from a point to that line of reflection is the same as the distance from the point's image to the line of reflection. So point A is the same distance from this line of reflection as A prime. B is the same distance as B prime from this line of reflection. The same goes for C and C prime and D prime. They're both equal distances. A reflection can be thought of as flipping of an object over the line of reflection. So if you fold the two shapes together, the line of reflection, on the line of reflection, the two shapes would overlap exactly. Notice there's no change in shape or size. This slide is just to remind you of the different vocabulary terms we talked that we deal with when talking about transformations. Remember that the image originally is called the object or the pre-image, and then once you reflect it or translate it or rotate it, or one word for all that is once you transform the object, you then have the image on this side. And for us, this example, this gives us a mirror line or axis of reflection, and the image is congruent to the original shape. Let's look at one more thing about this shape. Like here, take a look. Notice that if I map the A to A prime, B to B prime, C to C prime, and D to D prime, it creates something called a perpendicular bisector to the mirrored line or axis of reflection. So this is going to be big because it's going to help us to do rotations when this line, what happens if the line is slanted? So let me give you an example like that. Notice that now I'm reflecting over a line that is not vertical, not horizontal, but slanted. And with this slanted line, you would still maintain it being perpendicular. So I can move this all the way around. Okay, here's a horizontal line for reflection. Here's a vertical line, and here's a slanted line. For the video, we're only going to look at vertical lines like this and horizontal lines like this. But I do want you to realize that that no matter which way you're reflecting it, no matter what line you're reflecting it across, it will always create these perpendicular lines. That's creating a 90-degree right triangle right there. 90 degrees, 90 degrees, 90 degrees, and it's perpendicular. Notice equal distance too, right? Equal distance here and here. Okay, let's begin. We have 2 examples here. We're going to rotate these 2 points, the point 4, -4, and the point 2, 4. I'm going to enlarge it a little bit more so the graph is nice and big for me. Okay, like that. At the bottom, you have information that's going to come in handy next. So just make sure that you write this all down that you see and then follow along with me. And what I'm going to do is highlight our line of reflection with red. And then I will reflect the points -4, 4 and 2, 4 across this x-axis. And we're going to get the new image point, okay, the prime for this. Let's go ahead and begin. Let's do the, let's highlight the line of reflection. So for this example, our line of reflection is this red line, and I'm going to erase that. That's too big. Because then what happens if we're at like 1? Okay, let's go ahead and there we go. Okay, so this is our line of reflection, which is the x-axis. And let's look at the point 4, -4. It will be my blue point. So I'm going to go over -4, 1, 2, 3, 4, and up 1, 2, 3, 4. And we have that point right here. And we're going to reflect that across the x-axis. So I want you guys to take a look at this point here, 4, -4. It is 1, 2, 3, 4 units away from the line. Well, if I'm going to reflect, I keep the same distance from that line. And it's almost like I just are reflecting across a mirror or across any other shiny image to the other side. So if it's 4 units away, it will be 4 units away on this side. So 1, 2, 3, 4. And your point should be, I lost it, 1, 2, 3, right here. So first of all, I'm going to draw a dotted line from one to the other. Notice that this is perpendicular to the red line, so it's a 90-degree angle, and it's the same exact distance from this point to the line of reflection and this point to that line of reflection. And so this is our new point here, and that new point is still going to be -4, but then now we're at -4 for y. Let's go ahead and do the red, or excuse me, do another color. Let's do green. For 2, 4. So 2, 4 is going to be 1, 2, and 4 here, right there. And we're going to reflect it again across the x-axis. So you want to maintain the same distance, which is 4 units. So my new point will end up here. And this point is going to be 2, -4. So what did we do when we reflected across the x-axis? In a reflection across the x-axis, the point xy reflects onto image x, and then we change the value of the y. Notice that the x was still the same, but the y changed in value. They both became -4. So not only can you do it by calculating just the same equal distance, but there's also a little formula that you can use like with rotation. Let's now practice by reflecting over the y-axis. We did the x-axis last example. Let's now do the y-axis. So I want to first highlight the y-axis here with a red color. So this is our y-axis, and we're going to go ahead and reflect the point 2, 1, and I'll do that in blue. So 2, 1, 2, and 1 is here. And we're reflected across the y-axis, so that means that you want equal distance from here to the y-axis and on this side. So then I reflect it, and my new point ends up there. And my new point is at -1. Ooh, sorry, not -1. -2. Oops. -2 and +1. Sorry, that 2's messy. There we go. Okay, so -2, 1. Let's go ahead and do the next point, which is 7, 1. So 7, so it's 2, 3, 4, 5, 6, 7 is here, and 1 is here. And we're going to reflect that across the y-axis, so it has to have same distance. So 1, 2, 3, 4, 5, 6, -7. So my point is here now. And that new point is going to be negative 7, 1. So what did we do? Taking a look at the points, it looks like we switched the sign of the x, but we keep the y the same. And so, yes, in a reflection across the y-axis, the point xy reflects onto image negative x, y. So you're just giving the x to change the sign of the x value for a reflection on the y-axis. So that's basic. We looked at reflections of x and y-axis. What happens if our line is different than just the axis? So the same idea is still the same thing in mind. I'm still going to use red to highlight the reflection line. So make sure you write all this down. And then when you're ready to follow along with my voice, you can resume the video. So here is my line of reflection. It's at y equals 3. And I'm going to reflect the pre-image point 4, 2. So 4, 1, 2, 3, 4. And 2 is right here. Okay, 4, 2. And we're going to reflect it across the y equals 3. And it still comes down, if you don't need the formulas, because the formulas were only used for x and y axis. When you have a different line, you just use the same distance. So if it's 1 away, it will be 1 away up there. So my new image is going to be this red dot there, and that is at point 4, 4. 4, 4. Notice they are the same distance from the line of reflection. Let's look at another example. Oops, I just realized I did that in a red, but I should have done that in a different color. Let's go over it with green. There we go. Okay, let's do the other one in blue then. So first, let's highlight the line of reflection, which is x equals 2. So I graph that line x equals 2. This is why we discussed with you guys on how to graph a line, so that when you come to this section, you're already ready to go with your skills. So let's highlight that with red. Okay, x equals negative 2. That is, oh my gosh, that's incorrect on what I highlighted. I hope, did you notice that? I just highlighted the y-axis. Okay, excuse me. Here we go, x equals negative 2. Okay, right, we're on negative 2 on the x. And so we're going to reflect the point 0, 4. So 0, 4, 1, 2, 3, 4 is here. Reflect that across x equals negative 2. And it's 2 distance away from the line, so it will maintain 2 distance away from the line. And that's our new point. And our new point is at negative 4 and 4. Okay. Notice that they are the same distance from the line of reflection. So that's very important. And no matter what our line of reflection is, it's always going to be equal distance, but it gets very tricky when it's a slanted line. Okay, now that we looked at some examples of reflecting a point, only a point, across the x-axis, the y-axis, and we looked at formulas for that. Then we looked at reflecting a line across a horizontal and vertical line. I want you to then focus on what you would do for a shape, right? It's just three dots instead of 1 dot that you're reflecting. But I'd like you to write down these bullet points and answer these questions and bring all your work to class. Okay, in your notes, we talked about how do you reflect a point using a vertical and horizontal line. Discuss what must happen in order for you to do the reflection, and what must you check at the very end to make sure you did your reflection correctly. We will discuss how to do reflections across slanted lines later on, and we'll also focus on reflecting shapes once you guys come to class. So make sure you have your notes prepared and bring any questions that you have, and don't forget about your summary, which should be at least 3 sentences in length.